Rush hour at King's Cross, one of London's busiest underground stations. 6 different tube lines meet here, along with several railway stations, with 67 million passengers passing through it each year. The first steam railways began in 1825, and 25 years later King's Cross had become a terminus for steam trains arriving in London. The railways were not permitted to expand any further into the capital, leaving 750,000 workers who arrived each day to find a way to get to work in the heart of the city. This inevitably led to gridlock.
London of the 1850s was one of the world's largest cities. It was a massively growing industrial city and a port, the hub of the start of the British Empire. Interestingly enough, it was a very dense and crowded city. It was still largely built on its medieval street pattern, and it meant that people basically jostled together. People lived very close to their work, and it was a very crowded city full of cobbled streets, gas lights and horse-drawn vehicles.
150 years ago, London was grinding to a halt. It needed an ambitious solution to link the main railway stations to the city centre. There was only one way to go, and that was underground.
I think it's important to remember that for most people, the thought of actually going underground and travelling at speed underground was actually a very novel concept. And many Victorian writers saw death and doom and destruction to people who actually travelled on underground railways.
Newspapers such as The Times actually ran quite a fierce campaign against the railway, saying that even if it worked, technically it would never pay because people would never use it. They were speculating about underground passages soaked with sewage drippings and infested by rats.
One man, Charles Pearson, persuaded Londoners that they needed a transport network beneath the streets. He knew that if people could get in and out of the city easily, they could live further away, and the slums in London would become a thing of the past.
Charles Pearson was a lawyer associated with the City of London, and he was the person who really first pressed for the building of the Metropolitan Railway, which was the world's first underground steam railway. And Pearson basically came up with the idea of digging a trench down the middle of the road, of roofing it over, and running his railway in the bottom of the trench.
The Metropolitan Railway Company broke ground in 1860. The building method used was called cut and cover. It involved digging tunnels which were over 20 foot wide, laying 2 tracks side by side, and then bricking these over and replacing the road. The project was expensive, took 3 years to complete, and caused havoc to homes and businesses. The new tunnels were very shallow, running only feet below the surface, as can still be seen in Notting Hill. Numbers 23 and 24 Leinster Gardens are identical to all the other houses in the street, but their facade is merely a wall, 5 foot thick, complete with blacked-out windows and doors. They were built to fill the gap left in the row of houses when the line was built. The Metropolitan line opened in January 1863. It connected the 3 major rail terminals at Paddington, at Euston, and at King's Cross, with the centre of the city at Farringdon. The initial suggestion by Metropolitan Railway's engineer John Fowler had been to have the new underground railway running on compressed air, not steam. The idea was that trains would be blown through tunnels and sucked back by air generated in great compressors at each end of the line. But the system had a major flaw. The compressed air leaked continuously through the tunnel joints. The Metropolitan Railway was forced to borrow steam locomotives and rolling stock from the Great Western Railway in order to start its service. It was a revolutionary idea and an immediate success. It carried 40,000 passengers on its first day. The timetable ran between 8 a.m. and 8 p.m. with a train every 15 minutes. The time for the 3 3/4 mile journey from Paddington to Farringdon was 18 minutes, stopping at all stations. Not much slower than the journey time today. This new railway had an unusual difference.
When the Metropolitan Railway was first opened, it had been constructed with both 7-foot gauge, which was Brunel's Great Western Railway broad gauge, because it met end-on with the Great Western Railway at the Paddington end, and it had a third rail added, which also created a 4-foot 8.5-inch gauge track. That's Stephenson's gauge.
The gauge is the distance between two running tracks. This odd twin gauge arrangement ended when the two companies, the Metropolitan Railway and the Great Western, fell out with each other. Metropolitan went back to using Stephenson's gauge, still used by most railways today. Without the locomotives from the Great Western Railway, the Metropolitan was forced to supply its own rolling stock, and for this they turned to the engineering company Bayer Peacock.
The engine was a 440 tank engine. 440 is the wheel arrangement also used on the standard American engines of the time. And it had fairly large driving wheels, as a passenger engine at the time would have, and a very, very handsome beast. Very successful, used throughout the whole 40-year period of steam on the Metropolitan Railway.
The engines weighed about 46 tons in running order. They could carry approximately 1,000 gallons of water in their side tanks, and the coupled driving wheels were 5 foot 9 inches in diameter, driven by two 17-inch cylinders. These are the original coaches which were used in London in the 19th century. They have been carefully restored by a Railway Preservation Society. The dreadnoughts, as these carriages were known, were divided according to class.
The fares charged to passengers on the Metropolitan Railway would have been according to the class they travelled in. First class would have been used by top city people travelling to their offices from their fashionable West London homes. Second class would have been used probably by the middle level of management, clerks and so on. And third class, anybody else who needed to travel. And they would have travelled fairly uncomfortably and in very cramped conditions on wooden boards.
The success of the Metropolitan encouraged other companies to start up, and in 1874 London's second underground railway began running along the Thames embankment. This was the Metropolitan and District Railway. By 1884, a complete circular underground railway had been constructed as a joint venture by the Metropolitan and the District Railways. They called it the Circle Line, carrying passengers in its shallow tunnels just feet beneath Big Ben and the Tower of London. But the new century would bring a new technology.
The use of steam locomotives on underground railways, particularly on the Metropolitan Railway and on the District Railway and some others, became increasingly problematical as time went on. The intensity of the service increased, the intervals between the trains shortened, and passengers were increasingly aggravated by the terrible pollution conditions which existed down there. At the same time, there were technological advances which were occurring in America, for example, and in Germany particularly, in electric traction.
With electrification, the underground was able to expand. However, the extremely disruptive cut and cover method was no longer an option. London couldn't cope with the chaos to its roads, and so a new type of underground construction was needed. This was going to take the builders deep into the London clay.
This is a standard London Underground running tunnel, manufactured out of cast iron lining rings. And this slightly larger section of tunnel that we're standing in is called a shield chamber. This is where the Great Head Shield, the device used to help build London's underground railways, was constructed and then dismantled.
A South African engineer called James Henry Greathead invented a thing called a tunnelling shield. It was a kind of iron cylinder with a wall in which miners could actually work in safety in all the soft ground. The earth would be dug out in front of the tunnelling shield, and when a hole large enough had been constructed, the device could be pushed forward. The tunnel lining could then be erected behind the shield to hold the ground up, and then the process repeated.
The Great Head tunnelling shield enabled the London Underground to expand as a deep-level railway network. The shield was the single most important engineering invention used to create the underground. London, at the end of the 19th century, was filled with exciting transport innovations. Permission had been granted to numerous railway companies who were proposing deep-level underground routes. But the City and South London Railway was the first. In 1890, it became the first electric underground railway in the world.
The decision to actually use electric traction was a really ambitious thing to do at the time, because most electric traction systems that were in use were tramways. Getting the electrical equipment small enough to actually run in a tunnel and powerful enough to move these quite large trains was a big challenge. The only way they could do it was to put all the electrical equipment into a small locomotive. The power station for the line was down at Stockwell. The problems they had were that the distribution of electricity from the power station up and down the line was not very good. So as the locomotives got further and further away from the power station and started to approach the station in the city up at King William Street, they often found that they were completely underpowered. And as the trains struggled to go up and down the hills, occasionally they would grind to a halt completely and all the lights would go out, leaving the passengers stranded in darkness.
The trains had technical problems, and they were called the sardine box railway, or padded cell, because of their claustrophobic design. But the City and South London Railway proved that electricity was the way forward for the underground. Another electric power tube company began operating in 1900. The Prince of Wales, Queen Victoria's son, opened the Central London Railway. The line was built entirely in tunnels, 10 feet in diameter, and since it ran across central London from east to west, there was never much fear that it would fail from lack of passengers. Today the line is simply known as the Central Line and serves stations including Oxford Circus, Bond Street and Holborn. The Central London Railway was immediately popular. Over 14 million passengers were carried by the end of the first year. The system was liked because it adopted the American idea of a flat-rate fare. It also looked across the Atlantic for its new technology.
The original Central London electric locomotives were, well, they were called camelbacks because they had a cab in the middle and two sloping bonnets on either side, which were built in America by the General Electric Company. They were shipped to England in boxes and assembled in London. One of them was dropped off a barge into the River Thames and had to be fished out before they could build it.
The passenger cars were over 45 feet long and weighed 14 tons. Gatemen controlled iron-grilled gates at each end of the cars, allowing passengers to board. The railway used direct current for its traction power. The electricity was picked up by the locomotive from a third rail in the middle of the two running rails.
When you want to start an electric motor driving a train, if you start it with all the power all at once, it'll either go into a skid or the motor will blow up because it's had too much power when it's standing still. So you have to apply the power gradually, rather the same way as you change up in your gears in the car. And the way they do it is they put a grid of resistors in the circuit with the motor, and the resistance reduces the amount of current getting into the motor circuit. And as you want to accelerate, you gradually step out the resistances one by one, you cut them out. And if you listen, you can hear that happening, click, 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 as the train accelerates out of the station.
In 1900, London's population was fast approaching 7 million, and there was a heavy reliance on the tube to move people about quickly and efficiently. But there was a problem with the locomotives.
The time taken to uncouple the locomotive when you got to the end of the line and find another one to put on the other end of the train to return, to go back, was taking up a lot of time and reducing the service. So they introduced what was called multiple unit control.
They achieved this by putting two of the motors at one end of the train and two at the other, underneath the passenger cars. The resistors and electrical equipment were put into a space above the motors. All the driver had to do when he wanted to change ends was to shut down the cab at one end, walk down the train, and get in the cab at the other end.
Over the next few years, there was really a railway mania with many companies and organisations promoting railways, very few of which ever saw the light of day. But three did, forming part of today's Northern Line, Bakerloo Line and Piccadilly Line. And all three had been given sanction by the government to go ahead, but all three were running into financial trouble. And that's when the American financier Charles Tyson Yerkes came to the rescue.
Charles Tyson Yerkes arrived in London with his wife and several of his mistresses, leaving behind a shady past. Questionable business practices in America had led to a prison sentence for misappropriation of government funds.
Charles Tyson Yerkes is a fascinating character. To many people, he's the embodiment of the crooked Victorian businessman. But I think it's important to remember that, of course, he merely operated in the business climate of the day. He wasn't responsible for the first underground railway, but what he brought was basically access to several important things. He brought access to American money to develop the very expensive tube railways being built in London at the turn of the century, and he brought access to American technology, particularly in the electrical field.
By 1902, Yerkes had become the chairman of the newly formed Underground Electric Railways Company of London Limited, with a capital of over £2 million. Yerkes set about buying up the new electric underground lines. He also built a large power plant at Lots Road, Chelsea, an ideal location for being supplied with coal by barge from the Thames. He believed that if you supplied your own power, you increased your profits. The Lots Road power plant, still part of the London skyline, was built to American specifications. It was one of the biggest generating stations in the world, containing 8 turbo generators running at 1,000 revs per minute, developing 65,000 horsepower.
The opening of Yerkes' first tube lines in 1906 and the increasing electrification of his subsurface railways increasingly spelt the death knell of steam locomotives in use on the central area of London Underground. Progressively they were forced to the suburbs, and eventually the entire network was electrically operated.
When the Underground was first electrified, it was decided to use a 4-rail system, which is almost unique in the world. The positive one is on the outside of the rails, and then there's the one in the centre, which is the negative rail. That system was chosen with an insulated return because even in those early days of electrification, it was realised that if the return went through the running rails and through earth, it could cause problems with corrosion of water pipes and other metal in the ground, including our own tunnel segments.
Charles Yerkes had achieved his first goal by making an efficient electrically powered railway network. The system he set up at the beginning of the century is still very much in place. But how to give the entire underground network a uniform identity was Yerkes' next challenge. Modern styling and improved design were the answer. To create a uniform identity for his company, he employed a young architect, Leslie Green, to design stations that were distinctive and conspicuous.
The minute you see one of these stations, it says London Underground, because it uses the tiles, these maroon glazed tiles, always the same. You also have all those Edwardian obsessions with kind of an English variant on Art Nouveau. You've got craftsmanship and wood and no expense spared. So these were lavish stations in their time. And they've lasted the test of time extraordinarily well. The minute you walk into a Leslie Green station, you know you're on the London Underground. They made something like 11 Leslie Green stations in 2 years between 1904 and 1906, which is probably why he died a year later, they say, of exhaustion, aged 33. But he left behind an extraordinary heritage for London.
Yerkes didn't live to see his underground empire grow either. He died in December 1905 in New York. And the following year, Albert Stanley, another American, replaced him. Stanley brought even more American influence when he arrived from New Jersey and took over as general manager of the Underground Electric Railways Company. Albert Stanley made 2 outstanding contributions. Firstly, he bought the bus companies in London, the only mode of transport that made a profit. Secondly, he employed Frank Pick as his deputy in 1906. Pick became responsible for branding and styling on the Underground. This included rolling stock, upholstery, lighting, architecture, and even graphic design.
The Underground, when they first opened the new tube lines, had the names of the stations simply fired into the tiles at either end of the platform. One of the first changes they made, so that the station name was distinctive, was to have the name printed on an enamel plate with behind it a red symbol, so that the lettering is on white on a blue plate with a red disc behind it.
This became the symbol of the Underground Company and remains its corporate logo. This logo reinforced the way the 3 deep-level tube lines were seen to be part of the same company. It was called the Underground for the first time in 1908, and the name stuck. The newly branded company also modernised its stock as the modern tube continued to take shape. To increase efficiency, the Underground had to find a way of getting people on and off the trains more quickly.
They solved the problem by the 1920s by building trains which had sliding doors on the sides, and the tops of the doors followed the roof profile so that there was headroom for people to get on and off. And this stock became known as the standard stock because so much of it was built that it was practically standard across all of the Yerkes tubes.
The Underground had a modern identity and modern trains below ground, but it was about to play a major role in the shaping of modern-day London above ground. The Underground lines had expanded, and in 1908 one line came to the surface just to the north of London in open countryside. Within the next few years, an entire new community, Hampstead Garden suburb, developed around the base of the Underground station. Albert Stanley and his fellow investors realised that there was a great profit to be made in the expansion and development of the London suburbs, as did their arch-rivals, the Metropolitan Railway. Together, the two companies expanded their networks beyond London, creating a new suburbia.
The Metropolitan Railway had the smart idea of actually buying up land either side of the railway as it was developed out into the countryside, and then later using that land to develop their own housing estates. So they got the double benefit of not only the profits from the houses themselves, but also the profits from the people who bought those houses, then travelling in daily into London.
The centre of London eventually stopped being the place where people lived and worked. The rapid growth in desirable suburban housing meant that the city centre was reinventing itself as a place to visit for entertainment and shopping.
From very early on, the people who run the London transport system realised that what they were selling was not a transport system, but a city. See, if you're selling tickets on the tube, you don't say, come on the tube, it's great fun. You say, go to the theatre, it's great fun, and go by tube. Or you say, go shopping in the department stores, it's great, go by tube.
The Underground network expanded from the centre of London and out to the suburbs, reaching ever more people. But to make a profit, it needed even more passengers. Frank Pick, the assistant manager of the Underground, hit on a radical idea, a poster campaign to promote the tube, not just as a way of getting to work, but for leisure activities.
By the 1920s and 30s, the Underground was producing a really large number of posters, and they had easily fulfilled their function of just publicising the system and getting people to use the Underground. And they became much more than that. They became a way of actually promoting London.
So they've sold the West End as the place to shop, the place to play, the place to drink, the place to flirt, the place to do all of those things. Consciously, posters saying, come to the West End, it's great. Go to the theatre, it's wonderful. Go to Selfridges and spend your money and buy a 2-bob ticket. That's what they sold, and we bought it.
The marketing and poster campaigns exemplified the forward-thinking and innovation of the Underground. And in the engineering arena, older technology was still serving them well.
The original braking system that was used on London Underground was designed by George Westinghouse of America in the 1870s. It consisted basically of compressed air supply, which provided you with a constant supply of air, and the air was to use in the brake cylinders, and the brake cylinders were used to push a block against the wheel to slow it down during braking. On each car, a thing called a triple valve, and the triple valve recharged the brakes, released the brakes, and applied the brakes, so it had 3 functions.
Technical expertise and simplicity were the watchwords of the London Underground. Simplicity exemplified by Frank Pick and his hand-chosen architects. In 1923, Pick employed Charles Henry Holden to design the stations on the City and South London Railway extension. Holden went on to create a house style that rationalised the often chaotic layout and provided a much more modern facade, still seen in many underground stations.
The design was a very clever one, based on simple geometric shapes and using a modern material and concrete for the roofs, but using traditional brickwork designs for the main body of the building, and creating what now in retrospect is some of the best modern building designs in London and perhaps in the rest of Britain as well.
But in one key area, the Underground was far from simple. As the network expanded, it was becoming increasingly difficult to follow and understand the London Underground map. An alternative was needed. And so in 1931, draftsman Harry Beck produced the first diagrammatic map. His solution was radical. He redesigned the map as an electrical circuit, abandoning geographical truth for the sake of simplicity. The central areas of the map, which contain the most complicated interchanges, were enlarged in relation to the outer areas. Initially, London Underground rejected the design because it was too revolutionary and because it had no bearing on the real geography. They eventually published it in 1933, and it was greeted with enthusiasm for being clear and simple to use. The diagrammatic map is now a standard means of representing transport systems all over the world. By the 1930s, control of all the original tube companies was taken over by the newly formed London Passenger Transport Board. Its role was to oversee the continued expansion of the Underground. With the population of Greater London approaching 9 million, something had to be done to increase the flow of passengers through the system. It wasn't feasible to increase the tunnel size for wider trains. So in 1935, the cars were redesigned to accommodate more people.
One of the major problems of all the pre-1935 trains built for London Underground was that you had the switch compartment behind the driver, and that used up 15% of the available passenger space. By 1935, they had sufficient design progress to put most of the equipment below the floor. Motors were smaller, the compressors were smaller, all the power supply systems were smaller, and they produced these prototype trains in 1935.
Since its opening in 1863, the London Underground has played a vital role in the lives of Londoners, not least during the Second World War. During the Blitz, 79 tube stations were used as air raid shelters, accommodating thousands of people every night.
The 130,000 people who sleep every night in tube stations raise a good many problems. They get there early and so need something to eat long before bedtime. London Transport has established 6 depots where the food is received and prepared for dispatch to the station canteens.
The trains carried the Women of the Underground catering service, who provided refreshments for the thousands of Londoners who sheltered on the platforms on countless nights during the war.
The London Underground had one of the most efficient catering establishments. In fact, there was a total of over 75 which the catering department looked after. And so they took on the job of providing refreshment trains.
Buns, chocolates, timetables.
Now these refreshment trains ran roughly about twice a day, once late evening and once before the service started in the morning.
Tons of food are consumed every night. To prepare and deliver it is the work of over 1,000 people.
As well as looking after the needs of the people sheltering in the tube, 17,000 women took on jobs in the Underground. They created a thriving underground world, producing weapons in the munitions and armaments factories beneath the city's streets.
During the Second World War, large numbers of women came to be employed by the underground group, mostly in place of men, of course, who had gone off to fight in the armed forces. But they took on a variety of roles, not just working in stations, but also in engineering capacities, such as relaying track or working in the underground factories, building new rolling stock and repairing trains.
Millions of vital bomber, fighter and tank parts poured out from this underground arsenal to the Allied forces in all corners of the world.
The Underground was also important for the wartime Prime Minister Winston Churchill. The deep tunnels beneath Down Street Station became the subterranean headquarters for the War Cabinet.
This passageway would have been the way out of the station up until 1932, but it had a much more important role during the war years. The Railway Executive Committee used this area for their meeting room, and it's where some of Britain's most important decisions for rail movements, troop movements during the war years were taken. But it also had another important use. Up until 1942, when the War Cabinet rooms were completed, Winston Churchill came here and met with some of the Joint Chiefs of Staff and with the War Cabinet. Here at track level, the platform areas were converted for use as a telephone exchange, as kitchens, as bedrooms and offices, and what we're standing in was one of the dining rooms. There were two dining rooms here, and we can tell that this one was one of the executives' dining rooms, and that was because they had wallpaper on the walls and a bell push to summon the steward. That gives you an idea of what kind of noise must have been present while people were trying to work, eat, and even sleep as trains were passing by the site not more than 6 feet away from where we're standing.
Between August 1940 and July 1941, nearly 40,000 bombs and millions of incendiaries fell on London. Thousands of underground carriages were damaged or destroyed. But worse than the damage to the rolling stock and infrastructure of the Underground, several disasters befell the tube.
Probably one of the worst was at Bank Station, which is right in the heart of financial London, where a German bomb penetrated the ticket office roof and slid down the escalator shafts before exploding, and it took over 18 months to reconstruct the station from the devastation caused.
56 people were killed in this disaster. In 1940, South London's Balham station was also destroyed by a German bomb, which burst a water main, drowning 68 people who were sheltering there.
One of the worst civilian disasters during the Second World War took place at a partially built underground station at Bethnal Green in East London. Following a false air raid warning, a woman and child tripped halfway down the staircases, and in the ensuing crush nearly 200 people were killed.
This tragedy was so awful, the British government kept the details secret for nearly 2 years. After the war, the Underground required an enormous quantity of new rolling stock to replace what had been destroyed. The new trains took to the tracks on the District Line in 1953, just as the last of the wooden cars were scrapped. They were inspired by wartime technology.
Following the experience with aluminium aircraft construction, London Underground used that experience to develop an aluminium car body. Aluminium was a good material to use because it was 20% lighter than steel, it didn't rust, and you could also get away with not painting it. In fact, you could save 2 tons of paint per vehicle if you didn't paint it. So in 1953, they tried running an unpainted vehicle around the system, and it was soon accepted by the public. So from that day onwards, all London Underground trains were built of unpainted aluminium. And only since the mid-1980s, when we were hit by the scourge of graffiti, did London Underground start having to repaint vehicles.
As the new aluminium trains came into service, London Transport ceased its steam passenger train operation. In 1961, after nearly a century, the steam locomotives found their way into museum collections and enthusiasts' clubs. For London Transport, the future lay in automatic trains. They began experimenting with them on the District Line in 1962. On March the 7th, 1969, London Underground again took the lead when Her Majesty the Queen officially opened the Victoria Line, the first fully automated railway in the world.
It was a pioneer. And the way it worked basically was that the driver would close the doors at the station and press 2 start buttons, and the train would accelerate and proceed to the next station, brake and stop in the right place without the driver touching any of the controls. Each section of line was divided up into blocks, a few hundred metres long, and each block had a signal protecting it, on the basis that you never allowed more than 1 train into any one block at any one time. If you automate it, what you have to do is to tell the train whether the block ahead is safe to go into. And they do that by transmitting a code through the rails, through running rails, and this code is picked up by 2 receivers on the front of the train. And those receivers basically tell the train whether it's safe to go and at what speed.
The Victoria Line, with its new age 67 stock, was the most modern urban railway in the world. The busiest section of the line between Victoria Station and Buckingham Palace carried 15,000 passengers during the rush hour. With the opening of the Victoria Line, automatic fare collection was introduced to make the Underground more efficient. Passengers could purchase their tickets at machines instead of the ticket office. Their tickets were marked with a magnetically encoded strip that could be inserted into an unmanned barrier machine, giving them access to the platforms and the trains. This was an important time for the Underground. After relying on the same equipment and stations for the last 50 years, they were in dire need of refurbishment. In the early 80s, many of the stations received a complete facelift. Expansions and renovations took place, giving the Central Line a completely new look. The system runs daily, from about 5 in the morning till around midnight, when it shuts down for cleaning and daily maintenance. Maintenance gangs work at night when the track current is switched off. Some parts of the track are over 100 years old and require constant safety checks. Every bit of the line is walked every 48 hours to check for faults. But the age of the system was to be responsible for the London Underground's most recent tragedy. On Wednesday evening, November the 18th, 1987, a small fire started under an escalator at King's Cross.
The fire spread very rapidly up the escalator and right across the ticket hall. It's believed to have been started by a smoker dropping a match down the side of the treads on the escalator. It spread so rapidly that 31 people died in the fire, including an officer from the London Fire Brigade, and many more were seriously injured. London Underground itself did a great many changes immediately after King's Cross. There's a very strong no smoking policy within the whole of London Underground.
After the King's Cross disaster, the Underground went through a period of safety improvement and modernisation. It was also voted the 3rd most impressive attraction in London by millions of visiting tourists. But for 8 million people, it is just a way of getting to work. The rush hour is never a pleasant experience. During the morning and afternoon peak hours, around 210,000 passengers pass through Oxford Circus and 240,000 use Victoria.
London Underground has introduced 3 new types of trains on 3 of the lines. 1992 on the Central Line, and 1995 on the Northern, 1996 on the Jubilee. Their traction system uses what we call electronic power. And the electronic power means that you can control the train with computers. The old direct current motors have been replaced by what we call alternating current motors. The reason for using these new motors is that they do not require the mechanical parts of the old DC motors, particularly brushes and the extra windings of the armature. This reduces the maintenance liability and improves the performance of the motors. And that's what's now standard on electric railways across the world.
The Tube is a constantly expanding network. From its opening in 1979 by His Royal Highness the Prince of Wales, the Jubilee Line has been developed into a modern state-of-the-art railway. The Jubilee Line extension has taken 30,000 people 6 years to build. The additional 10 miles of tunnels crossed the River Thames on 4 occasions, and 10 new stations are now in operation on what is one of the most high-tech and advanced underground railways in the world. Architects Foster and Partners created the space-age look of Canary Wharf Station.
With projects such as these, there really is an interaction between the architecture and the engineering of the stations. They're very complex building projects. Canary Wharf was in a dock that had to be drained and then excavated still further, so they're very much below water level. So if you imagine the building being effectively floating in water, held down to the gravel levels below, every time you build another massive building next to it, it causes movement within the overall box. So the planning of that and the thinking of that from an architectural point of view and also from an engineering point of view were very complex.
The Jubilee Line extension employs the latest technology to deliver an efficient and safe railway system. Safety is paramount, and this totally new line can run large numbers of trains at any one time on the system. The trains are all new and are all controlled from their state-of-the-art nerve centre. Radio links enable the centre to be in contact with every driver, and onboard information systems keep passengers aware of changing travel details. But with nearly 968 million people using the tube every year, the system will need to be more widely modernised.
I think Londoners want an underground system which enables them to travel to more places in more comfort.
Tourists do seem to be markedly keen on the underground than native Londoners, probably because they don't have to use it every day.
I think more than anything, though, people want to be able to feel that they can sit in newer rolling stock, and I say sit rather than stand. They'd like a seat, so therefore they'd like more trains coming more quickly.
I think most people think that London is one thing and the London Underground is another, but in fact the two things are intermingled. In a way, the Underground is London. It's the only thing holding London together.
Plans now exist for passenger capacity to be increased by making better use of the available tunnel diameter, lowering the floor of the carriage and providing more gangway space for standing. This concept has been called space train, and gaps would be eliminated between cars by using short articulated segments to provide one continuous train instead of individual cars. It is hoped that the space train will transport 60,000 passengers per hour along the Victoria Line.
The Underground as we know it is just about full. There is no such thing as London without the tube. Of the 1 million people that came to work this morning, only 15% came in cars. 85% came by public transport. Half of them used the Underground for part or all of their journey. As the tube grew, that London grew. The railway system is what makes London live and breathe.
137 years ago, steam trains carried passengers beneath the streets of London on the world's first underground railway. Electric traction modernised and expanded the system, taking the tube lines deeper beneath the city's streets. As London's population has grown and the traffic problems increased, the tube has become indispensable, and it is now recognised all over the world as a symbol of London. The future promises faster, larger trains and line extensions. It may be the oldest underground system in the world, but is the London Underground ready to provide the city with all her transport needs in the 21st century?
Stand clear of the doors now. We'll be back tomorrow with another wide array of history programmes, starting at 8 in the morning with another chance to catch R. Lee Ermey's mail call. Join us then, or later if you can. For now, I'll wish you good night from all the History Channel team.